Good evening, students. Let us start today's topic: errors, accuracy, and precision in a measurement. Yesterday, we have learnt about measurements. Got? See, in every measurement, we can find some uncertainties. Means, and that uncertainties they refers to your errors. Suppose one example. Suppose someone will ask you to measure length of this room or time span between two events using your wristwatch, or while measuring the length of this room you are given your meter scale. So if 5 different persons are given to measure the length, I'm sure the readings of all the 5 cannot be the same. Why? Because a lot of things are involved here. One, the instruments given to all of them may not be same. There might be a fault in the instrument itself, and all the persons are different. So the procedure, whatever they will follow, that may differ from person to person. Because of this reason, or sometimes some accident occurs, yes, and the technique, the people, the person they are doing the measurement may differ from person to person. Because of all these reasons, so there might lie some uncertainties in the measurements, and that uncertainty is called your errors. Clear? So errors are the uncertainties in every measurements. Clear? Basically these errors are classified into two groups. One is your systematic and the second group is your random error. Random, as the name suggests, they are actually accidental errors. You have no control over it. See, what is the need to identify the errors? The need is to have a very particular value of your measurement, or to get the true value, or the actual value or the accurate value of your measurement. You need to you need to have the idea about the error, so that you can rectify and can find out the true value. Because of that reason we need to know the errors. See, random, they are accidental errors. We do not have any control over it. Clear? Now comes to your systematic error. Systematic error, why the name systematic? Because you know the nature of the error. Systematic error, their nature is known to us. So we can rectify these errors easily in our measurement. Example, suppose there is a watch, and that watch is running late all the time by 5 minutes, let's say. Clear? The watch is running late by 5 minutes. It is known to you. It means whenever someone will ask you about a time, a particular time, you need to add 5 minutes and tell the correct value. So you can rectify your measurement. So that error all the time, the watch is 5 minutes late. That kind of error is systematic in nature. Clear? That's why this systematic error, they affect your result in the similar manner each time. Got it? And the systematic error, they are further classified into these three groups. One is your personal error, second one is instrumental error, and the third type of error is imperfection in experimental technique or procedure. So how a personal error can be a systematic? Take the example in the personal level. Suppose we know the measurement of parallax. So parallax measurement, the parallax angle, that differ from person to person. Like the basis, the separation gap between the eye is different from person to person. So one parallax is different from person to person, and that can be rectified if you know which person is doing the experiment and how much parallax is there. We can easily measure. That's why you can rectify, and it's a personal error and differs from person to person. That's why it is personal error, and it's a systematic. every time that same person measuring the same physical quantity will get the similar amount of parallax. Clear? That's why it is personal. Now comes to your instrumental. Already I have given you some example, like your defective watch that runs 5 minutes late. So that error lies on the instrument itself. So because of that reason, that error is called your instrumental error, and it is systematic. We can rectify it. Clear? And the third type is imperfection in experimental technique and procedure. Clear? The simple example I can take how this can be a systematic error. Suppose someone given you a thermometer and he'll ask you to measure the temperature. Clear? The one person keep the thermometer just below the tongue, and another person kept the thermometer just below the armpit. The same thermometer at two different places can read two different reading, can give you two different reading. That's why. But it is known to us what is the temperature difference between the tongue and the armpit. So if it is known to us which procedure we are following, so we can rectify our error, and that's why this technique is called your systematic error. This means imperfection in experimental procedure, this kind of error is coming under your systematic error. Clear? And just what I have said, random error, they are actually accidental in nature. That we do not know how these errors are coming into our picture. So because of that reason, we have some other techniques how to minimize the errors in our measurement and how we will get a value closer to our true value. That I'll come afterwards after this accuracy and precision. Now comes to accuracy and precision of any measurement. Like suppose accuracy will tell you, okay, let me define first. Accuracy will tell you, that means how close is the measured value is to the true value. Got it? You have a measured value, you have measuring by using any measuring instruments, and you got one value. The actual value of that physical quantity is decided. So your accuracy will tell you how smaller the gap between the true value and the accurate value. Precision will tell you to what resolution or limit the physical quantity can be measured. It depends on the instrument itself. Got? Like using your meter scale, we can measure a minimum length, and the value of the minimum length we can measure up to your 1 centimeter. But while using a centimeter scale, we can measure the minimum value to be around 1 millimeter. So that is the difference. So I'll be giving one example where you'll be more clear about accuracy and precision. Suppose the true value of a physical quantity, measured physical quantity that you are getting, let's say it is 5. It's a true value of a measurement. You have two instruments. Using one instrument, you found the measurement to be 4.6. Using another instrument, you get the measured value to be 4.59. Got? You got two different reading by using two different instruments. Clear? Your true value of the physical quantity is 4.675. Out of these two, you see which one is closer to this, 4.6 or 4.59. See, if you find out the difference, you will see this 4.6 is closer to this value. Means we can say this measurement is more accurate than this. That's why the accuracy of the instrument is more in comparison to that of this instrument. Clear? Now, it means this instrument is more accurate. So its accuracy is measurements. This measurement's accuracy is more. Now come to this example 4.59. 4.59, you see, after the decimal place you can measure up to 2 decimal places. Clear? And here you can measure up to 1 decimal places. So the minimum measurement of this scale you can take, this will be 0.01, because if you take the minimum value here 1 and the rest will 0, so 0.01 is the least count of this instrument. Clear? Means up to the second decimal places, you can measure if you use this instrument, whereas if you use this instrument you can measure up to only the first decimal places. So that is the difference. Means here the resolution of the instrument is more, that's why this measurement is more precise. Got it? And this measurement is more accurate. But ideally any instrument you are using or any measurement, that should be more accurate, at the same time it should be more precise. Is it clear?